Very good. You have stated the Fermat-Little theorem. And now, are you ready to watch and listen? Yes, we'll have more discussions on Fermat-Little theorem, especially on its proof. Pierre de Fermat was a French lawyer. Yes, he was a lawyer in 1601 to 1665. Although he was a lawyer, but he loves mathematics. And one of his famous results is Fermat-Little theorem. Okay, so let's know more about Fermat-Little theorem. What's Fermat-Little theorem? It says that Fermat-Little theorem says that if P is a prime number, take note, P is a prime number, and P does not divide A. P does not divide A. Then A to the P minus 1 is congruent to 1 mod P. Okay, again, Fermat-Little theorem is if P is a prime number and P does not divide A, then A to the P minus 1 is congruent to 1 mod P. So let us have an example. Consider P is equal to 5. Okay, is 5 a prime number? Yes, 5 is a prime number. Okay, so let us have here 5 does not divide 2. So if 5 does not divide 2, it follows the Fermat-Little theorem. 5 is a prime number and P does not divide A, does not divide 2. So we can follow the Fermat-Little theorem here. So we can use A to the P minus 1 is congruent to 1 mod P. So what is your A there? A is 2. Your P is 5. So through Fermat-Little theorem, that will become 2 raised to 5 minus 1 is congruent to 1 mod 5. And that should be 2 raised to 4 is congruent to 1 mod 5. Okay, how about if it's 3? 3 is our A. Yes, how about if A is equal to 3? 5 does not divide 3. So 3 raised to 4 is congruent also to 1 mod 5. Okay, let us go back to 2 raised to 4. That's 16, am I right? Yes, that's 16. So if we will divide 16 and 5, the answer is 3 remainder 1. That is why we have there 1 mod 5. Okay, how about for 3 raised to 4? That's 81. So 81 divided by 5, that's 16. Remainder 1. So that is still 1 mod 5. Okay, how about if it is 4? 5 does not divide 4. So 4 raised to 4 is still congruent to 1 mod 5. How about the next number? Our A is equal to 5. At this time, 5 divides 5. So What can you say? Theorem does not apply. 5 raised to 4 is actually congruent to 0 mod 5. It is not congruent to 1 mod 5. Because when we will simplify 5 to the 4th, that's 625. Then divided by 5, that is equal to what? 125. Remainder. What is the remainder? No remainder. That's 0. Okay, so that is congruent to 0 mod 5. So the theorem there does not apply. Okay, so let's keep going. How about 6? 5 does not divide 6. Yes, 5 does not divide 6. So 6 to the 4th is congruent to 1 mod 5. How about 7? That is still 1 is congruent to mod 5. Or rather, 7 to the 4th is congruent to 1 mod 5. Then we have also 8 to the 4th is congruent to 1 mod 5. How about 9? 5 does not divide 9. So, that's the answer. Or that is congruent to what? Okay, very good. 9 to the 4th is congruent to 1 mod 5. How about the next number? 10. 5 divides 10. So what can you say? Yes, that's it. Since 5 divides 10, so that is congruent to 0 mod 5. The theorem here does not apply. So we cannot apply Fermat theorem for 10. Okay, because that is congruent to 0 mod 5, meaning its remainder is 0. Okay, so do you have questions? So you don't have any questions? Let's proceed. It seems like Fermat theorem is a very specific theorem because it does have a lot of use. It can also be used if the exponent is a very large number, if the exponent is something else. Okay, so let's have an example. We'll be using a very large number. Find the remainder when you divide 3 raised to 100,000 by 53. At this time, your P is 53. Yes. The question is, 53 a prime number? Is 53 a prime number? Yes. 53 is a prime number. Okay. And then 53 divides 3, or 53 does not divide 3. Which is which? Yes, that's it. 53 does not divide 3. Okay, so P is a prime number. P does not divide A. So, in here, we can apply the Fermat-Liouville theorem. So this will become 3 raised to 53 minus 1 is congruent to 1 mod 53. And 3 raised to 52 is congruent to 1 mod 53. Okay, so we have to look for 3 raised to 100,000. Yes. So we need to find a number that will be multiplied to 52 so that it will become 3 raised to 100,000. So let's have a simple trick for this. Yes, just a simple trick. Okay, so the trick is to raise both sides to a large power. Yes, we will raise both sides to a large power. So here's a way to find out. Just a simple trick. Okay, let us just have a straight division. Okay, so we have 100,000 and then that's 3 raised to 52, am I right? Yes. So we will just divide 100,000 and 52. Yes. 100,000 divided by 52. And what is the quotient? Okay. Calculate the 100,000 divided by 52. Okay, what's the quotient? 100,000 divided by 52 is 1,923 remainder 4. Very good. 100,000 divided by 52 is equal to 1,923 remainder 4. Okay, so that's it. We have 1,923. So we will make use of this 1,923. We will multiply 1,923 and 52 so that we can have a very close number to 100,000. Okay, so 3 raised to 52 raised to 1,923 is congruent to, at the right hand side, we will also be using 1,923. But at this time, any number raised to 1 is equal to 1. So the right hand side of the congruence won't change. It won't change. That is still 1 mod 53. Yes. Okay. So at the left hand side of the congruence, that will become 3 raised to 99,996. At the right hand side, that's 1 mod 53. All right. So we have now 3 raised to 99,996 is congruent to 1 mod 53. No, that is not yet 100,000. So what do you think will be used, or what number should be used, or what number shall be multiplied to both sides of the congruence so that the left hand side will become 3 raised to 100,000. Okay, so let us make use of the remainder 4. Yes, we can make use of the remainder 4. 900, or that's 99,996 plus 4 is 100,000. So what do you think? We need to multiply both sides by 3 raised to 4. Yes, that's it. We will multiply both sides of the congruence by 3 raised to 4. Yes. That's it. So that's 3 raised to 100,000 is congruent to 81 mode 53. Okay. 3 raised to 4 times 3 raised to 99,996 by applying the law of exponent, that is equivalent to 3 raised to 100,000. And that is congruent to 81 mode 53. And furthermore, through the use of Fermat little theorem, this can be simplified into 3 raised to 100,000 is congruent to 28 mode 53. Yes, that's the magic brought by the Fermat little theorem. That will become 3 raised to 100,000 is congruent to 28 mode 53. When you will simplify 3 raised to 100,000 and will divide it by 53, that will yield 28 as its remainder. That's it, the Fermat-Liouville theorem. So we will now have the proof of the Fermat-Liouville theorem.